Hello everyone. Welcome to the power plants technology lecture. Today we will talk about fuels and combustion. This lecture in particular will focus on the introduction and mostly the fuel we will consider here is going to be coal, because natural gas is a very sort of consistent fuel as far as the consumption is concerned, and as far as the um, overall combustion process is concerned, similar with the gasoline or diesel. But when we talk about coal, we will see that there is a lot of different processes which has to be taken place before we can burn coal for power production. We have nuclear power, which is going to be dealt separately, but right now, coal. So, um, in among all the fossil fuels used for power production, generally coal has the largest segment because um, different oils, diesel or gasoline and natural gas are also used in a lot of sort of industrial applications and residential applications, so their demand is very high. But coal is a substance which requires a very special amount of sort of process to actually be able to be used safely, and so generally it is reserved for a large amount of heat generation for industries or power production. Pakistan, for example, produces the majority of its power by coal power plants. So we can use wood dust as well as different other natural gas and oil fuels, but they are generally used as a supplement to the coal power plant, coal uh, furnaces. But generally, in a lot of power production, coal is the primary fuel used for steam production. So, coal, it is very important to understand that coal um, is not something which is exactly the same wherever you dig it out, right? Coal is an output of a process which takes millions of years, billions of years even, and so the output of that coal is highly dependent on the kind of forest and the kind of trees which were sort of deposited in the ground, the kind of ground, and the processes which happen to it, and how much time it has been sitting in the ground. So you can have, for example, like you can find graphite in it, you can find different type of coals in it, you can also find graphite diamond in the ground as well. So one interesting thing is that diamond in fact is not actually a very rare substance. Diamond is a very common type, like in among all the different gems and different sort of materials, diamond is actually pretty common. So the demand and the luxury of diamond is actually artificially created. We have the capability of mining a lot of diamond, and the diamond products will be very cheap. But especially with the advent of synthetic diamond, like we can produce diamond artificially, and which has similar or even better qualities than naturally found diamond, but it is artificially maintained, the demand is artificially restricted, so that the sort of production is artificially restricted, so the demand remains high, and diamond is sold at a much higher price compared to its sort of uh, value as far as rare materials in the ground are concerned. Gold, for example, is a lot more is a lot rarer than diamonds. So, but the price of diamonds is kept artificially high. So, but coming on to coals, we can see that the coal is commonly divided into four types, going from peat to anthracite. After anthracite, if the diamond, if the coal becomes 100% carbon, it becomes graphite. So it forms a specific sort of uh, crystalline structure, which is of graphite. So anthracite is a very, very large carbon content coal. Um it is again, it is a very rare kind of coal as well. It is expensive, so we use in the just the ignition part of the coal furnace. Bituminous is the middle sort of concentration of coal. So that is used in regular combustion, but it is again a very expensive sort of combustion coal. Then we have subbituminous, we have lignite, and then we have peat. Peat is a very, very sort of impure kind of a coal. It is not generally usable for upstream power plant. So sometimes when you see that there is a large deposit of coal found, and after a certain amount of time you just stop hearing about it, and you start to figure, like, if you start to wonder what happened to that coal mine which was discovered and which had a very large like amount of coal sort of declared upfront. But what happened to it? So a lot of times the coal is there, but it is too far deep into the ground, and it is not of a quality which is good enough to actually mine it out. Which same happens with a lot of natural gas and gasoline products. Same thing happens with a lot of different metal deposits as well. So a very, very sort of impure product, or a product or a ore which is at a very sort of deep underground configuration is sometimes not feasible enough to mine. So this is peat. If it is dug, it is used for district heating. Lignite is something which is used in steam power plants, but it is still a very poor quality of coal. It it then it goes through processes of dehumidification, and it is used in a lot of your industries. Pakistan generally has lignite and subbituminous type of coal in present, commonly being mined here. So the coal content is here, but it's not of a very good quality. And this kind of coal also produces a lot of sulfur and different other harmful products. So you can see the different type of sort of uh, products, so different type of constituents which are present in coal. So the primary thing which defines coal is fixed carbon, right? If a substance does not have fixed carbon in it, it is not coal. So generally we define the coal starting at 30% carbon, which is lignite. Then the second part is volatile material. Volatile material is something which is combustible, like for example sulfur compounds, or for example even carbon compounds, but they are present in a separate arrangement. There could be hydrogen in it, there could be anything else in it. So these volatile material actually help burn this coal. So when you ignite this material, this ignites this coal as well. And lastly, you have moisture. Moisture is present in coal because this coal is a product of coal actually comes from trees. So any tree or any organic material has, any living material has moisture in it. So moisture is actually uh, present, and it starts to decrease as the life, as the age of the material starts to increase. So you can expect the anthracites and meta anthracites to have a lot less moisture content, because a lot of the percentage of the material is carbon, and you can expect the low quality coals, which is lignite, to have a lot of volatile material and a lot of moisture as well. So in, for example, these cases, you actually need to put these in a dehumidifier, dehydrator or dehumidifier, and you need to remove some of the water content as well, because this water content will actually restrict combustion in the furnace as well. So when we actually acquire a new sort of shipment of coal, we are interested in how much carbon, uh, volatile material, and moisture is in coal. So what we do is we analyze the coal for different materials. So there are two type of analysis. One is the proximate analysis, one is the ultimate analysis. So proximate analysis you have seen earlier as well. It was uh, how much do we have fixed carbon, how much is the volatile material, how much is moisture, and how much is ash. So as I've talked earlier, volatile material is not fixed carbon, it is not elemental carbon, but it is something which is also easily burning in the system. So for example, it could have CH4, or for example other material which is present in the coal, but it is not fixed carbon, it is not elemental carbon, it could be hydrogen or any other thing. Moisture is simply H2O, you know that. And ash is the residue which is left after you burn coal. Like you've seen as well, when you burn a specific amount of coal, all the material that is left in the system is ash, and you have to deposit that ash in when you need to refill the coal. So this is again obviously the easiest way of finding out how much ash, how much percentage of this coal is ash. You just completely burn this coal at 720 degrees Celsius. 720 degrees Celsius means that all of the moisture will be evaporated, all of the volatile material will burn, and all of the fixed carbon will burn as well, leaving only ash in the system. And similarly, when you want to talk about moisture, you just heat it until the boiling temperature of water is reached. And you obviously, you have crushed this coal, you will take a very small sample of maybe coal powder or something, and you just heat it very slowly in the absence of, for example, air, and you just restrict this 105 degrees Celsius to, um, you don't need to actually remove air from it as well. You just need to heat this sample of coal for a period of 1 hour, and all of the moisture will just simply evaporate out of it. So when you remove this moisture, uh, but this sort of volatile material, ash and fixed carbon still remains in the system, and you just get the weight difference. For example, 1 gram before heating goes to 0.7 grams. That means 0.3 grams or 30% of the material was moisture. When you want to find out the volatile material inside this um, this coal, then what you do is you take this material which has lost all of the uh, moisture in it. You take this sort of sample, you put that in 950 degrees Celsius for 7 minutes in the absence of air. That is important. Why? Because if you add oxygen to it, this material will burn, this coal will burn, and you will lose both the volatile material as well as the fixed carbon. So when you remove oxygen from the system and you only heat this at 950 degrees Celsius, what happens is this volatile material sort of evaporates and goes out of the system. And when you have taken out ash, volatile material, and moisture from the system out, then you just get the fixed carbon So you can see that if you take out ash, moisture, all of the volatile material, then you are left with carbon, fixed carbon in the system. Uh, that this up till this point, this was proximate analysis. Proximate analysis, we are not concerned about what is the composition of this volatile material. But in ultimate analysis, we are concerned about the different materials. So now we actually find out what the molecules were here and what sort of percentages they have here. We just talk about moisture and ash, although you can separate this moisture in hydrogen and oxygen as well. So now when we have the composition of coal figured out, then we are interested in the combustion equipment for burning that coal. So we generally have four type of uh, furnaces for coal. They are called fuel bed furnaces, pulverized coal furnaces, cyclone furnaces, and fluidized bed furnaces. So we will talk about different what their constructions are like and how does that name tell us what this the combustion process will be like. Um, so in a fuel bed or a pulverized coal furnace, we have a sort of furnace bottom, like we have a bed and we are just dumping coal over it and you get fresh air, and this sort of happens, the combustion happens here and you get hot CO2 plus air plus other components H2O जो भी whatever you have here plus etc etc, but mostly carbon dioxide and the excess air you get. So if you are dumping this coal over a bed of old, like for example you have an older bed of coal which has air passing through it, and if you dump coal over this old bed, this is called overfeeding. And if you try and ram this coal under this bed of old coal, for example, like you have this coal which has already burnt in the air, and you add fresh coal under this bed, so this is called underfeeding. There are different mechanisms for both overfeeding and underfeeding. We will check these later on in the slides. Um, so now we will start with the mechanisms for um, feeding coal into the. So the first kind is called a mechanical stoker. Mechanical stoker, you will see in later examples. They are different type. They are traveling rate, spreader stoker, vibrating rate, and underfed stoker. Underfed is again the example where we saw that you try and add coal under the bed of existing coal so that air interacts with the fresh coal before it passes through the older layers. All the other examples, especially the traveling rate and the spreader stoker, and even the vibrating rate, they are all overfeeding examples. Uh, you will see later slide. Yeah. So you can see that this is called a traveling rate. This is sort of this is a barrier. If you shut off this barrier, then this conveyor belt will not take any fresh coal into the furnace. You can see that there is air coming in. PA is called primary air. Uh, Primary air main objective is to try and burn as much of the coal as possible, but this coal will also have some carbon monoxide added to it. So what we do is we add another batch of fresh air, which is called secondary air, so that uh, can meet with this carbon monoxide and produce carbon dioxide. This is to burn, basically this is to burn all of the impurities here. And what happens is this grate takes this coal, and this coal moves on the bed, and the fresh air comes in at a high temperature, it burns, and you waste the ash to a ash pit. This process, as it looks, is very simple. This is just sort of, what do you call it? This is a perforated grate. This has channels for air to pass through, and this just burns coal and just deposits the ash to the ash pit. But what happens is, if the chunk of coal is large enough that it might actually waste some of the unburnt coal into the ash pit. Also, it allows some of the ash to flow into the flue gases as well. So this is a very simple process, but this is not sort of a very modern kind of a design, which it does not allow you to vary the speed of combustion by a lot. This is just a very specific system which is a little inefficient as well. Then we have another kind. Now you can obviously see in the last design that you will have a large quantity of coal at the initial part when the conveyor is moving, and at the end of the part, this air will not find a lot of coal, a fresh coal to actually burn. So here what we do is, there is another type which is called a spreader stoker. Spreader stoker actually helps you spread this coal all over the fuel bed, and this fuel bed has very small gates which will allow it to deposit all of the ash to the ground. So what it does is, it relies on the coal size. That coal will maintain its shape until it is completely burned, and when it is completely burned, it will become ash, and it will just go down and out of the combustion chamber. And it also does is, it has this lever. When you pull this lever, these these push in this direction, and you have the ash which is again dumped out of the system. So this is a second type, which is a spreader stoker. Again, these are relying on large chunks of coal, and they are a very sort of slow process to produce heat at a constant flow rate, which is fine as well as far as your applications are concerned, but they are not designed to be very proactive, and they are not designed to be very efficient. They are just simpler systems. The third type of stoker is a vibrating stoker. What the vibrating stoker does is, it just basically uh, vibrates the fuel bed. So for example, you have a large amount of coal here and a large amount of ash which is deposited everywhere. So what this does is, it just uh, vibrates the bed, so that coal material actually gets out of this ash, and ash sort of gets dumped um, into the ash pits. So obviously, if the boiler load is large, then we have a different amount of vibration depending on what the fuel intake is. If the boiler load is low, then we might not need a very large frequency or amplitude of the vibrations, because the fuel bed is very small. So these are changeable. And underfeed stoker, which shown here, is it has this old layer of carbon, and what it does is, it pushes fresh coal intake, and which gets combustion from the air intake. So what it does is it burns air, and this is pushed outwards, and there is fresh coal coming in every second, and so these go further into the uh, ash pit. So this is okay, yeah. So this is these were the type of stokers. Stokers involve large chunks of coal. Now we will discuss about pulverized coal furnaces and how they are different. And again, then we will talk about cyclone furnaces and how they are installed. So hopefully you will look at different examples of coal furnaces and the feeding mechanisms through your book MML Vakil, and as well as just go online and search for mechanical stokers in coal combustion, and you can see different type of um, combustion beds. We will talk about how the coal size starts to change in the coming lectures. What kind of bed requires what kind of coal, and what type of coal and what kind of coal size, and it's everything. But right now, just review the different structures of the coal um, beds, coal furnaces, and we will have a discussion about it in the interactive session. Khudafis.